All right. So this target has a diameter of 28 centimeters. Okay. So the target diameter of 28 centimeters. So the radius is what? 14. Okay. It has 4 scoring zones formed by concentric circles. It says the diameter of the center circle is 4 centimeters. The width of each ring is 4 centimeters. Okay? So the dart hits the target at random. Find the probability that it will hit the point in blue. Okay? So the blue is what we want to happen, right? That's what we're interested in. So the area of the blue is going to be the numerator. All the things that could happen, I could throw a dart at this thing and I could hit anywhere inside where my cursor is, right? Inside that circle. I could hit anywhere inside that circle. So that would be the denominator. Okay? Now we just got to figure out, so it says 28 is the diameter. So let me come over here and draw this. The diameter of the whole thing is 28. So from there to there is 28. Okay, you can't really see that. Let's do it in white. I'll say the diameter. Okay, so the radius is 14. My fault. Okay, so that distance is 14. Diameter, yes, diameter 28. That's 14. The diameter of the inner circle is 4 centimeters. So that means this distance here is 2, right? And then it says the width of all the other ones are 4. So that's 4, that's 4, that's 4, and that makes up my 14, right? Okay? So when we do this, the area, first thing I want to figure out is the area of the target. I need the whole thing, right? That's going to be my denominator. So I always do that first. I always figure out what is my sample space that I need for this problem. So the whole thing is the largest circle up there. Yeah.
What do you like go through it? Just so I know I'm the area of the whole thing, and then the area of the white thing, and then find the area of the red one, and subtract the white from red, and then divide it by.
If I was trying to find just there, I'm trying to find the blue though. I'm trying to find the blue. Yeah. So area of the target is going to be, in this case, it'd be 14 squared times pi. So that's the area of the whole target, right? Okay. That is going to end up being my denominator. That's my sample space. Okay. My numerator is just the area that's blue. Okay. This is how we've got to figure out the area that is blue. This is kind of visually, I think, going to help you. If I did that, can you figure out the area that is blue? Okay. So going back to what we had in the picture, okay, this was 2 plus 4 plus 4, right? And this outer one was 4 again. Okay? So that distance right there is how much? 10. Okay? So that was 10. Now, if I find the area then that is blue, that would be 10 squared times pi, right? So 100 pi. Okay? Now, does everybody see that when I now find the area that is just red? Does that make sense? So if I find the area that is just red, remember this was 2, and then from there to there was 4, right? So the area that is just red is going to be 36 pi, correct? Okay. What would I do? Okay, so this area here is, if I were to go, see my cursor? Okay, so it'd be the area of everything inside that circle that my cursor would be tracing out. Is that right? Okay. The area that I have written in red there, 36 pi, would be the area inside where the circle that my cursor is tracing out now, right? It would include that white stuff. What would I do with these two areas to actually get just the blue ring? Subtractive. Okay? So when I say the probability of landing in the blue region, that would be the blue area divided by then the total area. Well, the blue area, you told me, was the difference in these two things. So it's 100 pi minus 36 pi. All over then the total area of the target, which is 196 pi. Okay? What happens there, if you wanted to do this, you can grab a calculator and type that in right away. But if you wanted to, do both numbers up top, that's pi. Factor that out, you get 100 minus 36, right? 100 minus 36 is 64, correct? Okay. Would the pi up top and the pi on the bottom cancel out? Huh? But I factored it out. So I did this. So if I take the pi out, now I have 100 minus 36. And I got 196 pi, right? Well, 100 minus 36, that's 64. So I got pi times 64 over 196 times pi. Can I just take those pi's out and write 64 over 196? Yeah. And now I can do that. Okay? So if that's what I want, I do 64 divided by 1. Regardless, I'm going to have to grab my calculator and technically get decimal. So if you want to leave the pi's in, leave the pi's in. If you don't, take them out. Yes? I'll use it for 64 pi. You can do it that way, too. Okay? I wanted to show you why you can actually do that. Why do I write it at 64 pi? Because I factor pi out, and then I do the subtraction with the rational numbers, and then I can put that pi back in and get the 64 pi. Does that help? Okay. And if you think about this, when I find that that area of the blue, okay, that was finding the area of the circle defined by the blue outer radius. Meaning, so this blue ring has two, and we talked about it as an annulus yesterday. But when I talk about an annulus, there's two radii for every annulus. That is, do it in white. That radius there, okay, from here to there and then all the way through the white. That is the outer radius. This radius here would be the inner radius of the blue. Does that make sense? So if I take the circle defined by the blue's outer radius, that would give me the 100 pi. And then I take the circle that is defined by the inner radius, which would give me the 36 pi. If I subtract those, that's going to give me my area of my angle. Okay? And that's the case all the time. So if I wanted to find the area of, let's say, the red one. Okay? I was trying to find the area of the red one. We would start. Let me try to figure out a different color here to help see us a little bit better. Let's use that color. Yeah, area. All right, so if I wanted to go to find the area of the red one, I would find that would be kind of my outer radius. Does that make sense? Okay, that's still maybe not a good color. It looks good on my computer, but that's worse. All right, so that radius right there, that would be the outer radius for the red annulus, right? Does that make sense? This here, that there would be the inner radius, okay, of that annulus. If I subtract the circles defined by that outer radius and the circle defined by the inner radius, that will always give me the area of that annulus, that red ring, okay? I have a problem using words like ring because it's not a math word, okay? And you're not going to see that too much in other areas. They'll use the word annulus. Okay. If that still eludes you, there are several videos on my website over that question, okay, and variations of that question. So please, if it's still confusing, take the time to go look at those, and that'll hopefully alleviate some of that confusion. Are there any others on there that you guys want to talk about?
Other harder ones?
I don't know. I didn't do it.
Neither have I. Why not?
Okay, so if we haven't done it, you should probably have done it. Looked at it at least.
I looked at like the first 6.
Okay.
If you